Welcome to this unit where I want to talk a little bit how we can use the weighing of cases in SPSS to make our sample a little bit more representative. Well, what do I mean by this? Let's have a look at a short introductory example. I have a data set here, as we see in this context, with three variables: gender, which is basically 1 is male, 2 is female, income with 5 different possibilities, and location with 2 versions: 0 is online, 1 is offline. Well, let's start with the first variable, get an impression on the gender distribution. And in this case, we just have males and females in our sample. Sample size in total is 872 participants. About 3/4 are males and approximately 1/4 are females. Well, so far so good, but if we have the problem that in our population there's actually a 50-50 distribution between males and females, this is not really representative for the population. So how can we change this? Well, we can use weighing of the different participants. So since we have more males than females, we would have to weigh the males less, the values for the males less, and the values for the females more. So we need respective weights by how much more the female values should be weighed and by how much less the male values should be considered. Well, how do we get these values? For this, I copied the absolute and, more importantly, the relative percentages from the SPSS output to Excel. I also will note the distribution which we are looking for in our sample. So in this introductory example, we're looking for a 50-50 split. The important part, you can basically set any percentages here. They just have to add up to 1 to 100%. Once we've done this, we're already prepared for the main calculation, which is simply dividing our preferred relative frequency by the actual relative frequency. We do this for both values, so we do this for the males and for the females, and we get these two values, 0.66 and 2.02. Well, this is the weight for the males, so it's smaller than 1 because, as I said, we have more males than we want to, so we have to value them or weigh them less, and we have too few females, so we have to weigh them more. And that's why we have these factors for males and females here. Well, how do we actually use them? Well, first off, we have to tell SPSS that for all male participants, so for all cases which have a gender value of 1, he should use this weight, and for all cases, all participants, all observations which have a 2 in the gender variable, he should use this weight. Meaning we need a new additional variable. And we get this variable if we go to transform, recode into different variables. Here we're going to select gender. We're going to give it a new name. Let's call it G for gender and weight. And we're going to go to old and new values, and simply where before it was a 1 for a male, we're going to assign it as a value this weight here. So we're going with 0.6646, and for the females, which was 2 as a value, we're going to use the weight 2.0185. I'm going to add this here as well. Then I click on continue and OK, and I will get a new variable here. That's again similar to the gender variable, but instead of 1s and 2s, it has only those 2 values. To use this variable, we're going to go to data and to weight cases. There we're going to switch to weight cases by and use this new variable. Well, nothing happens here, but internally he has applied those weights. And we can see it if we just go back to analyze descriptive statistics, frequencies, and again calculate our frequency table for gender. We do this here. We see now it has a 50-50% split. It has the same number of cases it had before, 872. And here are like pseudo cases where it's split exactly into 50-50. Well, this works for 50-50, but this works for every other weights as well. So if I want to have instead a 10-90 or a 20-80 split, I could just go with 0.1, 0.9. Then I get the new values here, the new weights here. So I have to go back again, adjust my weighing variable. So I have to go back to transform, recode, and with this variable I have to adjust my weights, which I set here. I'm not going to do this in detail, but in the end it would work like this. Well, it would work not only for two variables, so not only for more or less binary variables, but it also works for variables with more than two values. For example, the income variable. If we look closely, here we have 5 different outcomes. And I prepared this as well here. So if I were to make a frequency table for the income variable, that would look like this. So this is more or less the same I realized here in Excel. And I can select different weights in this case as well. For example, I could say I want to have 20% here, 10% here, 30% here. Here I already added up everything I had so far to know I'm not overstepping the 100%. So I could, for example, go with here it should be 5%, and at here it should be 35%, adding up to 100%. Again, to get my weights, I'm simply dividing the preferred relative frequency by the actual relative frequency. Do this for all 5 cases. And then I'm going to use these 5 values for weights. So again, transform, recode different variable. Now I'm just going to reset this and use income. I call this then income weight. And with all the new values, I do the same thing as before. The first category was 1, so 1 gets a value, the first weight of 2.725. Second category gets the second weight, so 0.4542. Third one, the third weight, 0.7267, rounded. 4 gets the fourth weight of 0.2725. And finally, the fifth category gets the last weight of 3.1792, rounded. Click OK, and OK. Get another new variable. And now I'm just going to switch with data, my old variable with the new one. By the way, if you compare these values, which we had here, with those ones, and you might have been wondering before, well, they look a little bit different. Yeah, this is the case because I left the weight cases by active. So, and that might be a problem. If I have one of the variables active here, he will always work with this respective split. So those are actually the results I would get if I have a 50-50 split with the gender. If I do not want to have this, I would have to go back to not weigh cases. If I repeat this here, I will actually get the same numbers as with Excel up here. So that's actually a point to really take care of. You saw how easily I fell into this trap myself. So this might actually be a very big problem if you switch between weight cases and unweight questions. Well, back to our example. Now we want to do this with the results regarding the income weights. So I use this variable, I go back to frequencies, do the same frequency table for income, and I see I have the preferred split, which I defined before in this example. So it works as well for multiple categories. It works for 2 for multiple categories. It works for any kinds of weights which I set, as long as all weights add up to 1 or to 100%. Well, so far so good, but there's a big problem because up to this point I only used a single variable. However, in more realistic situations, you would want to have representativeness for more than one variable. Maybe you go with, it should be representative regarding gender, age, and income. So you would have to combine 3 variables. In this context, by the way, I said have it representative. Well, in this case, it actually works out decently well. For example, we see here, we have more than enough observations per group. So it actually can work out. It becomes more representative. But if we were to have one group with only 3 or 4 observations, then you can weigh as much as you want. It will not change that your data set is not representative at all. So you need to have decent enough numbers to start with to actually get your data set to become decently representative. So it can only enhance representativeness, but a certain level needs to be there in the data from the outset. Well, back to the problem I mentioned. What do we do if we want to combine more than one variable in our weighing scheme? Well, we can start with the easiest version. We can start with 2 variables with just 2 values. So I use the gender and the location version. As I said, location just has 2 values, 0 and 1 for online and offline. So if I want to do this, first off, to get the reference case, I have to go back, do not weigh cases, same problem as before. Now we can use descriptive statistics, cross tables. I could put gender in the rows, location in the columns. And well, as I mentioned before, I'm not only interested in the absolute values, the absolute frequencies, I'm more interested in the relative ones. Here I get them if I go to cells, percentages, total, click continue, okay. And I will get this cross table here, which is more or less absolute frequencies and relative frequencies, which I prepared in Excel. They add up to 1, so far so good. And now I need to decide on my preferred frequencies. For example, I could find out that in my population there should be 10% males who shop usually online. There's approximately 30% males who shop offline in total. Again, I just added up all here. Whereas for the women, it's like 25% here, 35% here. So I can select any distribution here which represents my population in the best way. And then I simply do exactly the same way as before by calculating the weights. I just take my preferred relative frequency and divide it by the actual relative frequency. Do this for all of my cases here, or my situations here, and get these weights. So I have to weigh this situation where I have too many, less, and all the other ones I have to weigh more higher. Well, the problem is, how do I get this into a single weighing variable? And for this, I have to do one step before all of this, which is I have to calculate a new intermediate variable. I can do this with compute variable. Just call this intermediate inter, And here I'm going to add all the involved variables, so gender and location, but I have to do one thing more. Gender is a 2-value variable. So the next one gets a factor of 2 in front of this. If I would have a third factor, maybe I would want to take income as well. I would go with plus income. I would have to go with gender has 2 possible values. Location has 2 possible values. So here I would have 2 times 2 possible values. So I would have to multiply this with 4. Well, in either case, we're just working with gender and location. So I'm going to use gender plus 2 times location, generating me this additional help variable, this intermediate variable. Let's have a short look how this variable looks like. Just check if I actually, I switched it off. So let's go to frequencies and put the intermediate one here. So I see I have 4 possible outcomes, 4 values. So I can consider how do I get this value. This one actually results from mails and online. So this part here is 1. The 2, I can also see this from the frequencies, the 2 results from females online. The 3 results males offline, and the 4 females offline. Of course, this works decently well with 2 variables. With 3 variables, 4, 5, 6, becomes very problematic to note it in this way. So in this case, I would rather prepare a table, go with male online, female online, male offline, female offline, one after the other, write down the preferred and the actual frequencies, and then calculate the variable. So I can do it a little bit easier, but I would still need this intermediate variable. Well, in either case, I have this intermediate variable. I know which weight, those ones here, is assigned to which value of the intermediate variable. So I could just go to transform and now do the same thing I did before, but with the intermediate variable. So here I would go with, let's call this weight. I would do exactly as I proposed. The value 1, the one in the upper left, male online, gets the weight. Sorry, I have to delete all the old version values. Should have reset this. The value 1 gets the first weight, so 0.1772. Value 2 gets the weight below, 1.3457 rounded. 3 gets a value on the top right, 1.5951. And finally, value 4 gets the weight down here, so gets 5.6519. Okay. I have my new weighing variable here, which again I can put with data weigh cases as weighing variable. Putting it here. Okay. And then I can just replay that part with the cross tables. Click OK here. And I see I actually now have a distribution, a weighing scheme, which reproduces exactly these frequencies which I wanted to have. Well, so far so good. Of course, I cannot only do cross tables, frequencies tables, I can do all the other analyses, which would then be based on distributions like this. Well, in either case, there's one aspect left to talk about, and that is, what do I do if I do not have these frequencies, but only those ones? So what if I only get marginal frequencies? So if I only know the distribution in my population of male and female, and the distribution of age and the distribution of income, but not how many or which percentage of males from generation Z earn between 1,000 and 2,000 euros. Well, in this case, I can use the small roundabout trick. Let's consider I want to have these frequencies here. So I want to have these values and these values. That's what I find, for example, in statistical yearbook. I have these values, but I do not know those ones here. Well, there's no big deal with this, because in this case, I can simply multiply this value with that value, which would assume that only those relations hold. Everything in here is equally distributed, which is no problem in our situation. And I can do this for all of my 4 situations here, giving me these percentages. If I scroll a little bit up here, 0.5642, 0.5642. So this actually reproduces the relative frequencies we would need here. So we can use this to actually get our preferred relative frequencies we would need to then do our weighing with. So even if you just have marginal frequencies, this still suffices to actually calculate your general frequencies and thereby the weights which you need to actually do the weighing on the basis of all involved variables. Well, that's about it on what I wanted to talk about, how we can use the weighing to make our sample a little bit more representative. So I hope you enjoyed listening to it. I hope you got some out of this session, and I wish you good luck with your ongoing research. See you next time. Goodbye.